Hello! Previously we talked about casting. We mentioned that casting is the process of assigning a value of a data type into a variable of another data type, and the variables' data types should be compatible with each other. For example, you may cast integer to double and double to integer, as each of them are numbers, but you cannot cast integer to string or any number data type to a string due to the incompatibility between the numbers and strings. We also mentioned that implicit casting is automatically done without being handled by the developer, but explicit casting should be handled by the developer. The same thing is applied to classes data types. We can also apply casting between variables of some classes data types if those classes are compatible. You can cast a variable of data type class X into another variable of a data type class Y only when classes X and Y are compatible. But let's know that the compatibility in this case is the is-a relation between the classes. And now let's have a look at this sample. We have animal class, which is the superclass of cat and dog. And now we will make some casting trials between each of them. Let's say animal A equals new animal, dog D equals new dog, cat C equals new cat. And now, as we see, we have references for each of those classes, animal, cat, and dog. And now, what if we say A equals C? It's compiling successfully. Okay, what happened in this line? That we have assigned the value located in the reference variable C into the reference variable A. Okay, what if we commented this line and let's say C equals A? Is it valid? Let's save. As we see, there is a compilation problem. So what have we do now? We must make explicit casting in this case. Let's type cat between brackets before A, and in this case it is compiling successfully. What's the difference between this line and this line? Let's remember the implicit casting and explicit casting. What happened in this line is implicit casting, but what happened in this line is explicit casting. And now in this line, can I handle the casting manually? Yes, I can, by typing animal between brackets before C, and it will also compile successfully, but we don't need it in this case as it is implicit casting. Okay, why in this line we don't need to handle the casting manually? Look at the relations between the animal and the cat. As we know, cat is a animal, as cat inherits from animal class. So in this case we are assigning an animal to an animal, but in this case we are assigning animal to a cat, and as we know, cat is an animal, but animal is not a cat. So we must cast manually at this case to perform the explicit casting as required in this case. For sure, we can also say A equals D due to the same reason in this line. As we know, dog is also an animal, and if we say D equals A, for sure we will need to handle it manually by making explicit casting by this way, as we see, and in this case it will also compile successfully as this line. And what if I say D equals C? Look, as we see, it's not compiling. Okay, what if we want to cast it? As we notice, also casting is not valid. Why? That's because there is no relation between dog and cat. As we know, dog is not a cat, and also cat is not a dog. So the same thing when will we say C equals D and also try to cast. As we see, also the same result. So in order to perform casting, there must be the is-a relation between the two sides you are performing casting to them. And now let's remove those lines and let's have a look on some methods inside animal, dog and cat classes. Let's have a look first on animal class. As we see, this make sound class is printing animal makes sound, and let's have a look also on cat class. It's overriding the make sound class, which is printing cat makes sound. Dog also overrides make sound method and is printing dog makes sound. And now let's call each of them a.make_sound, d.make_sound, and then c.make_sound. Let's run and print. As expected, the first line printed animal makes sound, the second line printed dog makes sound, the third line printed cat makes sound. In this sample, each reference variable has executed the implemented method inside its class type. And now, what if we make an implicit casting between A and C and assigning C to A and then call A.make_sound? What do you expect this method to print? Will it print animal makes sound or will print cat makes sound? Let's run and see. Do you notice A is of type animal but executed the method inside the class cat? The question now is, what happened in this line to make that difference? As we know, cat is an animal, so we could assign the value of C into A. Before this line, A was referring to an object of type animal which was initialized in this line, and C was referring to a cat object which was initialized in this line. And what happened in this line? Let A, instead of referring to this object, became referring to this object. That is the reason that let reference variable A after executing this line, that let A executed the make sound implemented in class cat. Let's also try to debug now and see what happened inside the memory step by step. Let's debug. Switch. And now let's start. After this line, now we have a reference variable of type animal and is initialized by an object of type animal which takes this ID as we see. After this line, we will have dog and then we have cat. In this line, A.make_sound will execute the make sound implemented in the class animal, as in this line A was still referring to an animal object. Let's skip it. And the same thing in this line, D will implement the make sound implemented in the class dog, and C will execute the implemented make sound inside the class cat. Look at those variables after and before assigning this line. Let's have a look on A and C, and then let's execute and see the difference that will occur after assigning this line. Let's have a look on the change that will happen in A. As we see, A now became a cat, not an animal, and taking the same ID as the reference variable C. So in this case, is no longer referring to the previous object it was initialized by. So it will execute the make sound which is implemented inside the cat method, cat makes sound. That's it. As we see, okay, after this line, the reference variable A became referring to a cat object, but can variable A access the methods located inside class cat but not located in class animal? Let's see. Let's have a look first on class cat. As we see, cat has this method which is called cat method, and this method is not located inside the class animal. So let's return back here and try to say a.cat method. As we see, it's not accessible by the reference variable A. Okay, so let's try to type it by force. Cat method. Let's save. As we see, it's not compiling. Let's read the reason. The method, cat method, is undefined for the type animal. So, why we cannot access this method in the reference variable A despite being assigned by a cat type reference variable? There is a difference between the compile time and run time. When we assigned C to A, the compiler accepted it, as it understood that both of them are animals. The compiler also understands that reference A is of animal type, so it will never access any method not existed inside the class animal. That's what is understood by the compiler. But during the runtime, the JVM understood after this line that reference variable A became referring to object of type cat, so it must own the cat method and able to execute it. That is true, but we need first to do something the compiler will understand to compile this code first, and then that thing will successfully do what is required. This thing is to make explicit casting in this line, and that is by typing cat between parentheses before the variable A, and after that surround this sentence between another parenthesis by this way. And now, as we see, the compiler accepts it. So what will we do? We will run now and see the result. Let's run. As we see, this line compiled successfully the method cat method, which is located inside the cat class. And now we saw a sample that is acceptable during the compile time but not acceptable during the runtime. Is there another sample that do the opposite? Let's see. Let's remove those lines now. And here we said that if we typed A equals C, it will be acceptable. But if we typed C equal A, we must do explicit casting in order to be acceptable by the compiler. And then when you type C dot make sound, or copy this sentence instead of C, let's open parentheses and then copy this sentence. As we know, it will also get the same result. Let's run and see. That's the result. Let's replace it by C. Run again. As we notice, the same result. But let's say A equals D in this line and then save. As we see, this program now is compiling successfully. But will it run successfully? Let's run and see. As we notice, we got an exception, which is of type class cast exception. This exception was occurred in line 14, this line. That's because it failed to cast dog to a cat. After this line, we have assigned a value of dog type into a variable of animal type, which is acceptable by both the runtime and the compile time. So the exception didn't occur in this line after both compile and runtime. But in this line was also acceptable by the compiler. As we know, there is a relation between the cat and the animal, so that we make explicit casting between A and C. But during the runtime, when the program reached to this line, it found that A is referring to a dog object, not an animal, and dog is not a cat, so it couldn't cast dog to cat, as we see. Okay, in this tutorial we learned how to perform casting between objects. We learned when it is acceptable and rejectable in the compile time, and when it is acceptable and rejectable by the runtime. Thank you for watching. Bye bye.